Okay, next problem is just from 5.2. It's page 279, number 12. Not a difficult section if you know what everything is. And this is modeling the population of Gary, Indiana. Mechanization and the use of machinery has meant that cars are more easily manufactured with fewer people, so the population is actually declining. It's not growing exponentially, it's decaying exponentially, and by a factor of a little bit less than 2% per year. So this is the population in 1970, because when x is 0, it's 1970, and of course if x is 0, this becomes 1, and 1 times that means that's the population in 1970. If we're going to graph that, and that's all this question is really asking you to imagine you're graphing this, this would be the starting population right there. This is going to be 0. This is 1970, and the population is going to decline very, very slowly like this as time goes on. If we make this decades, 1980, 1990, and year 2000, you'll see that maybe the population then will go down faster depending on the scale that we choose. But exponential growth and exponential decay will come down in this case and then hug the 0 line if you give it enough time. Now obviously in the real world it's rare that cities decline to 0, but in the short term it might follow that pattern of growth. Anytime you see a decimal less than 1, you know it's decay. Anytime you see a decimal more than 1, you know it's exponential growth. Okay?